Hi guys, this is Ms. Miner, and today we are doing lesson 2E. 2E. And our goal for this lesson is to be able to set up and solve a two-variable equation. And you'll start recognizing our two-variable equation. It's a very special equation that we're going to work with a lot during the next few units. And we have two variables. This is kind of its formula, but the two variables that we are going to see in our formula today are y and x. And this equation that we're going to be setting up, we in math call it our slope-intercept equation. Our slope-intercept equation. And it's very, very special. And you may have heard of it before, but we're going to use it today. We're going to use this setup to help us start figuring out what are the parts of this two-variable equation that are very, very special to us, and what do they mean? And so we're going to use some real-world problems. Some word problems, some real-world word problems, and we're going to start to try and understand what the parts of this very special two-variable equation mean and where we see them in the real world. And so we're going to just kind of start a beginning introduction into two-variable equations and working with our slope-intercept equation by using some word problems to help us figure out what are the parts of this equation representing. So in our two-variable equation, our two variables that we're going to use are the variables y and x. And we use those a lot moving forward. Those are kind of the standard two variables. And then you'll also notice us use two other variables, the letter m and the letter b. And we'll kind of start working with those. Those letters represent our slope and our y-intercept. But today, in order to kind of understand them in context or in relationship to the real world, we're going to represent those using the words per because we see that word a lot in the real world, like miles per hour and feet per second and things like that. We see the word per a lot in the real world. And so to try and understand what these variables are actually representing, we're going to use these word problems, and we're going to try and set up these equations, and so we can kind of start to understand what this equation is representing when we set it up and when we work with it. And so we're going to use the word per to represent this part of our equation. We'll come back to m later on and use m later on, but for today we're going to say that what we're going to fill in the blank here is whatever in our word problem, we're going to look for the word per. And then over here, we're going to look for some kind of, oh, whoops, that's not what I wanted to do. We're going to look for some kind of fee or possibly like a starting amount. I like to, rather than fee, sometimes I like to say starting amount. And y, in this case, our variable y is going to represent our total. So we're going to be working with some numbers and some amounts, it looks like, in order to come to some kind of total. And our second variable, our y, is going to represent our total. So here are some of the things that we can look for, some of the words that we can look for that we will represent like per, right? The word per, or this amount that we're looking for. In our word problem, we'll see words like each. If I say these are 2 cents each, well, that means 2 cents per item. So the word each could be also another word that we look to fill in this blank, right? To help us set up our equation, because we're going to be setting up these two variable equations today. And so we're going to want to write an equation. And so these are the words that we're going to look for in order to help us. Multiple items, right? I'm going to buy 7 tickets. So multiple items. A repeating charge, something that they are going to charge me $3 every month. So that is a repeating charge, right? $3 per month. That would be a repeating charge. And so that's the kind of number that I would want to have represented here in my space where we're using the word per to kind of represent that space or that blank that we want to fill in. And we're going to fill it in with some number. And then over here, this could be, oh, see, I did put it on here. A one-time charge, a fee, an upfront cost, or a starting value, okay? If I'm talking about growth of plants, maybe one of my plants starts at 2 inches high. That would be a starting amount, right? Rather than a fee that would be charged. And so that would be like the starting value, something like that. It depends on what my context is asking or talking about, right? And then here's a very important word that we're going to use a lot in this next few units. It is the word independent variable, and that is what we call x. X is the independent variable. Sometimes we will reference y as the dependent variable. Because my total, right, whatever my total is, it's going to depend on how many or how much of the stuff that's happening over here. So x would be my independent variable, and a lot of times x represents some amount of time, right? Or, yeah, like some amount of time, like seconds. And so it's independent. If you think about time, time is not dependent on anything, right? Time is going to go by no matter what we do or how much we're buying or how quickly we do something. Time just goes by on its own. It's independent. And so a lot of times our x variable represents some amount of time, not always, but that's a good representation because time is something that is very independent of what we're doing, right? And so x is our independent variable, and y is our dependent variable because our total is going to depend on all of this other stuff that's happening over here. Our total is going to change depending on what's happening over here with the rest of my equation. So we call x the independent variable, and we call y the dependent variable. But today we're going to think about it as a total because a total is something that we're very, very familiar with and we're used to working with. So that's how we are going to kind of be thinking about the parts of our equation that we're setting up. We're going to use this idea of total, or y equals per x plus v, in order to kind of just start to begin to understand what this 2 variable equation is representing and what the parts are. Okay, so here is a situation, and remember we're using the setup y equals per times x plus some kind of fee or starting value. Okay, that's kind of our setup. We want to write an equation that represents what's happening in this context. And it says, for a membership to an athletic club, it costs $150 to join and $28 per month. Aha. Here's a word that we were looking for, right? Per month. It says write an equation, and I'm just going to kind of underline this part. Write an equation to figure out how many months it will be before here's another word like what we were looking for, right? Total cost is $290. So remember, y also represents our total. Oh, I want to switch back over here. Our total. And so we can't forget that, right? So we want to set up an equation. Total equals per x plus some kind of fee or starting amount. Okay, so let's find it. We definitely know what the per part is. This is per month, right? And so this number that's going to be in here is $28 per something, right? Remember how I said X usually represents some kind of time? Well, X in this case, oh, sorry, I'm crossing it out. I meant to highlight it. X in this case then is representing my number of months. Because we are talking about per month, right? 28 times how many months I have my membership, right? So my X is going to represent the amount of time or length of time that I have my membership. I hope this is kind of starting to make sense. And then my total, right, over here, my total cost for my membership depends on what per month cost, right? And then also I have to pay $150 up front. That's a starting amount, right? That's a fee that I have to pay just to get the membership. And so that's what we're talking about back here. So my total cost, total dollars for my membership is going to be 28 times the number of months that I have my membership plus $150 to join. So now we can kind of start to understand what our equation that we're setting up is representing. Then we can go ahead and solve our problem. So I'm going to change colors here really quick because it also tells me a total amount, right? It says figure out how many months it will be before my total is 290. So now I'm going to rewrite this equation again, but with less, like I've filled this in with a lot of words. But I'm basically saying 290, right, is my total. And I have 28x plus 150. So how many months? Well, remember, X was representing my amount of time, right? My number of months. And so I'm going to solve this equation and find out what X equals. That'll tell me how many months until my total is $290. So I draw my line down, right? I subtract off my extra hostage. This is going to go to 0. 28x is equal to, let me just calculate this really quickly. $140. Oh, I could have probably done that in my head. And then divide by 28 to get x by itself, right? So x is equal to 140 divided by 28, which is 5. So 5 months, I would have to have my membership for 5 months before my total cost would be $290, right? So maybe this, in this case, this is like in the real world, maybe I'm trying to figure out my budget, right? And my budget is $300. And so I want to know how many months of membership to this gym could I have before I met my budget, right? My budget of $300 a year for my membership. And I could have, so maybe that would be a case where I'm like, oh, I don't know, 5 months isn't really worth it. Or, oh, I could, go for about half the year before my budget for my gym membership ran out. So that might be something that I would have to consider. So that's kind of how we figure this out. We use it in the real world. Okay, this also works for, is my big mug at the movie theater worth buying? Right? So here's the cost for my drinks. And here's my cost for my big mug. I can set up an equation, a 2-variable equation, and try and figure out how many months or how many times would I have to go to the movie theater before it would make my big mug worth it, right? So if I visit the movie theater 3 times and order a large drink each time, what's my total cost? Oh, I couldn't remember what I had hidden back there, so I had to remember. Okay, so let's set up an equation and solve it, right? Here's my total over here. You can actually calculate, your cost. So this is the per, and here's our fee, what I have to pay up front, right? Or my starting amount. If I go to the movie theater 3 times and order a large drink each time, what is my total cost? So if I go 3 times, right? Well, let's go back a screen. Let's look at the large drink. Here it is. Let's highlight it. Here's my large drink. It's $4.75 for a large drink. So that's per drink, right? So here is my per $4.75 per drink. So X in this case is going to be my number of drinks. And whatever my per is, right? This is $4.75 per drink. Whatever this bottom number is, whatever it is, the per part, right? That's what X represents. X is my number of drinks because $4.75, right? And then times how many drinks I order. So X, remember X is timesing that. And so whatever this is per, that's my X is my number of drinks because I'm multiplying that amount by however many drinks I buy. So hopefully that kind of makes sense where I'm getting my X from. And then is there an upfront cost to go to the theater and buy a drink? No, there's not. So my fee up front, my starting amount would be $0, right? So in order to figure out what my total cost would be, I say, okay, I'm going to the movie theater 3 times. That's what number I'm going to put in here for X. So Y, my total, is equal to $4.75 times 3 plus 0, because there's no upfront cost. Now I can leave this off if I want to. I don't have to put the plus 0 on, but I just want to show you like that is still there, right? That fee is still there. So I just do $4.75 times 3 and $14.25. So my total cost, $14.25 for 3 drinks is $14.25. Okay, so now I have this equation set up and I want to bring this out. If I buy a refill mug and fill it up 3 times, what's my total cost? So now we have to go back and take a look at the refill mug over here. And it says that if I pay $14.75 up front, here's my starting cost, right? My fee. Then my refills are only $1.50. So now this is my per part, right? Per drink. So let's set up an equation and figure out what it costs if I have a big refill mug, right? So now I'm going to set up the same equation, y equals per x plus fee. But this time I'm going to use the big refill mug things. It was $1.50 per refill. So this is the number of refills. And then over here, this was $14.75. So let's solve it and find out what my total cost is. If I go to the movie theater 3 times to refill my big mug, what's my total cost? So I'm going to put my total cost is equal to $1.50 times 3 now, because that's my number of refills, plus $14.75. $1.50 times 3 is $4.50. Plus my $14.75 gives me $19.25. So my total is $19.25. So if I go to the movie theater 3 times, is it worth it to buy the big mug? Not really, because my total, right, just to have was, what was it, 14 something? I can't remember. Now I can't remember. $4.75 times 3 was $14.25, right? This was $14.25 up here. So going to the movie theater 3 times, if that's all I do, then buying the big mug is probably not worth it. So let's write this over here, right? This was $19.25. And then I'm going to erase it because we're going to try one more thing here, right? So here's my 2 equations for the cost of my big mug and one for the cost of just the total drinks, right? This was drinks. And how can we use those 2 equations now to help us figure out this thing? How many times do I need to visit the theater with my refill mug to make it cost effective? Well, I know 3 isn't enough. So there's a couple of ways that I could do this. I could guess, right? I could guess some numbers. But there's a really quick and easy way that you already know in order to be able to solve this, right? These are both equal to my total. This is equal to my total. This is equal to my total. This total represents total amount for my big mug, right? 150x plus 1475. And I want to know, when is that cost? When is the cost of my big mug? When is this total equal to the total for just buying a regular drink? 475x plus 0. When is that equal to that? When are those 2 totals equal? When I know that number, when I know when the cost is the same, then I'll know how many times I have to go to the theater to make it cost effective, right? So I can set those 2 totals equal to each other and solve it and find out exactly how many times, right? I already know how to do this. I have an x over on this side. I have an x over on this side. I just want to get rid of one of those x's. So I'm going to subtract $1.50 from each side. This one's going to go to 0. 1475 is equal to 475 minus 150 is 325x. And then I divide by 325 to get x by itself. And this cancels. And x is 1475 divided by 325. And I have to go about 4.5 times to the movie theater before my cost was the same, right? I get kind of a long decimal number when I divide these 2 numbers together. But essentially, if I round that off, it's about 4.5 times to the movie theater. So how many times would I go to the movie theater to make it cost effective? About 5 times, or at least 5 times. 5 times. And this was something that you guys already have been doing. You've already solved equations like this before. And so we're getting really good at it. We can kind of start to figure out how people do math in the real world, right? And we can use this idea of this 2 variable equation to help us figure some real world problems out. So this is very important information. We got to know if the big mug at the movie theater is worth it and how many times we got to go to the movie theater to get our drinks, right? So now we know we have to go to the movie theater about 5 times in order to make our big mug refill worth it. Okay, let's see. All right, let's do one more of these before we move on. Okay, Mrs. Zider wants a new gym membership. Lehigh Legacy Center charges only $24 a month with a $30 one-time fee. And Gold's Gym is offering $10 a month, but their one-time fee is $100. So let's write an equation that shows both gyms. Let's just first start writing let's write 2 equations that shows the cost, the total cost, right? And y is our total. And then we have our per times x plus our starting amount or our fee. And then we're going to do one for Lehigh. This will be total for Lehigh. And then let's do another one. Y equals, or total cost is equal to per times X plus fee. And this will be for golds. First, set up your two equations. That's kind of the most easiest or most helpful way to kind of see what's happening, right? So for Lehigh Legacy, it is $24 a month. Is that the same as per month? Yes, it is. So my per amount here, let's change colors just so that we've got it, is $24 per month with a one-time fee of $30. So that's what I'm going to put over here. So the total cost for Lehigh is 24 times the number of months. X would represent the number of months because that's what it's per, right? So times the number of months plus 30. Then Gold's Gym. Let's change my highlighting feature over here. Gold's Gym is $10 a month. So I'm going to put that over here in Gold's Gym. $10 per, this is my number of months. And then their one-time fee is $100. So that's what's going to go in here. Now, this says, show when both gyms would equal each other. Oh, now I'm not highlighting anymore. When would they equal each other? So I want to know when this total is the same as this total. So I want to know when 24x plus 30 is equal to 10x plus 100. I want to know when those two things are equal to each other and how many months. Remember, this x right here is representing our number of months. And so we want to know when those months are equal to each other. It says, oh, sorry, we have a bunch of equations or a bunch of questions that we're trying to solve here with these three equations. So let me take this equation right here and let's just move it out of the way for a second because we're going to answer some questions first. It says, which gym is the cheapest after 1 month? So remember, X is our number of months. So if I want to know which one is cheaper after 1 month, then I take both my equations, 10x plus 100, right? And I put the number of months into the equation. So I'm going to put a 1 in for X. Y is equal to, let's switch this back to green so that we are just working in the right color. So for Lehigh, I want to know when my total, right, 24 times 1 is equal to 30, or sorry, not equal to 30, plus 30. So 24 plus 30, after 1 month, the total cost for Lehigh is $54. So now I'm going to put a 1 in over here. The total cost after 1 month for Gold's Gym is $110. So that's after 1 month, right? So for 1 month, if all I wanted was 1 month, then Lehigh Legacy would definitely be the deal that I wanted, right? Okay, last thing that I want to know here is when would they be the same? Okay, so now I'm going to use my third equation that I came up with where I set them equal to each other because now I want to know when is their cost equal. So I'm going to give myself a little bit more room and I'm going to use my equation here that we came up with, right? When are those two things equal? When are they the same? And so now what I need to do is just solve this equation for X. Find out how many months, the number of months it would take for those two equations to be equal. There's my equal sign. I'm going to go ahead and subtract 10 x's from both sides. And this is just our regular old equation solving. This would be 14x plus 30 is equal to 100. Then subtract the 30 from both sides. I'm going to run out of room, so I'm going to finish writing it over here. This is going to go to 0. 14x is equal to 70. And then divide by 14 on both sides. This is going to go to 1. X is equal to 70 divide 14 is 5. That's my number of months, right? So I would have to have my gym membership for 5 months in order for the cost of Gold's Gym to be equal to the cost of Lehigh. So if I were looking at how many months before this higher fee, right? This is lower per month, but higher fee. How many months would I have to have that membership? I'd have to have it for at least 6 months, right? In order to make the cost effective. Otherwise, they're just equal to each other. But when would they be the same? At about 5 months. And now I know. Okay, that's how we're gonna work with these equations, and hopefully you guys have a kind of a good understanding. But please remember that Mrs. Zeider and I are always available to answer questions. You're welcome to email us anytime, and we'll try and get back to you as soon as we can if you're having questions at home. You can also join us on our Google Meet Wednesdays at 3 o'clock in the afternoon with any questions that you have. All right, thanks guys. Have a good day.